Okay, so question 8 this time. Again, looking at electropotentials, asking us to evaluate the reduction of bromine to bromide ions. So if we identify that reaction in the first instance, we can see that the equation that we're looking for is this one here, the second one in the equation list. And that is the reaction that is going to need to go in the forward direction. If we establish the electropotential for this one, it's got a positive voltage of plus 1.09 volts, which means that any voltage which is lower than it will be forced to go in the reverse direction. Okay, and that's ultimately the premise of this question. What that means then is that bromine, in order for it to be reduced to bromide ions, will need to react with either of iron 2 plus, vanadium 3 plus, or H2SO3. That very quickly eliminates the dichromate ion at the top left-hand side, which has got just too big a voltage. That will actually react with bromide ions rather than the bromine molecules themselves. That then gets rid of question A, so that's not the answer. Likewise, it also gets rid of answer B, which is to do with iron 3 plus. Iron 3 plus is on the wrong side of the equation. If you see that one just underneath the bromine, it is on the wrong side of the equation here, and so won't be reacting either. Bromine will react with iron 2 plus, as we've already established. So we've very quickly eliminated it down to a straight competition between either the vanadium 3 plus ion or the H2SO3, which is answer C or D below. Now, the key to this question is actually the numerical values that you're given. We're told we've got to reduce 0.012 moles of bromine. A quick MV over 1,000 situation evaluates that the vanadium 3 plus and the H2SO3 plus in both of these situations actually generate the same number of moles of bromine. However, the key to this part here, though, is the number of electrons that they generate. Vanadium 3 plus, for an equimolar concentration, will actually generate half the number of electrons that the bromine requires. Bromine requires 2 electrons. Vanadium 3 plus will only generate 1, so it won't generate enough. H2SO3 will generate, for an equimolar solution, will generate the same number of electrons that the bromine requires. So the more likely correct answer in this situation is going to be answer D.